Okay, guys, so continuing with coordinate geometry, we are now going to talk about parallel and perpendicular lines, okay? But this time they're going to be on a coordinate grid or a coordinate plane. So let's start off with reviewing slopes of a line, okay? So you should be pretty good at that because that's from Algebra 1. So in this first picture, we have two lines. And let's find the slope of line A and line B. So I see, let me get a different color. I see a point here, and then I see a point here. You always want to make sure that they are pretty clear on the coordinates. And then for the line B, where do I see a coordinate? I see a coordinate here, and I see one here, and I see one up here. So let's do the rise over the run because that's what slope is. So this one rises up 1, 2, 3, 4, 1, 2, 3, 4, and over 1. Up 4 over 1. So that's 4 and that's 1. Okay, and let's double check the next one. This one goes up 4 over 1, up 4 over 1. So the same slopes, okay? So if it rise over run, remember the rise is vertical, the run is horizontal. So 4 over 1 is just simply 4. Same thing here, up 4 over 1, so it's just 4. So the slope, okay, and in case you forgot what M stands for, that stands for slope. Okay, I'll review that again in a little bit. But so the slope of line A is 4, and the slope of line B is 4. Okay, let's look at this next picture over here. This one intersects. So let's look at the points here. And actually, these points were drawn for you. So we'll just use those. So this one goes up 1, 2, 3, and runs over 5. Make sure it does that again. It goes up 1, 2, 3, and runs over 5. So I'm going to put a 3 and a 5, 3 and a 5. Okay, let's check the next one. This one goes down 1, 2, 3, 4, 5 over 3. 1, 2, 3, 4, 5 over 3. Okay, so down 5 over 3, down 5 over 3. So when we write those slopes out, again, we're going to do rise over run. Okay, so line C, the rise, and it's a positive direction. Remember when it goes up to the right, so it's going to be a positive 3 over 5. Okay, and you can't simplify it after that. This next one, line D, this one goes down 5. So this one's sloping down, so that's a negative slope. So that's going to be negative 5 over 3. Okay, so these two first lines, A and B, they appear to be parallel. Okay, they're running side by side. They have the exact same slope, so I would assure that that is indeed parallel. Over here, what do these two lines appear to be? These look like they could be, that's a pretty close to a 90-degree angle right there, the way these two lines intersect. So these two appear to be perpendicular. By the way, the parallel symbol is two straight lines like that. This is the perpendicular symbol. I'll write it out as well. Okay, so these two appear to be perpendicular, these appear to be parallel, and in this case, they both are. So some things to remember about parallel and perpendicular lines on a coordinate grid is that when the slopes, when you have slopes of parallel lines, these are always going to be the same slope, okay? So these are going to be the slope if lines are indeed parallel. Okay, over here, what you call these over here, we had a 3 over 5 and a negative 5 over 3. Notice the numbers are the same, they're just switched from the numerator and denominator, which you should probably remember that from algebra to be the reciprocal. And then one is positive and one is negative. So those are like opposite of each other. So when we talk about those kinds of slopes, the lines of parallel and perpendicular the slopes of perpendicular lines are going to have opposite reciprocal slopes. opposite reciprocal slopes. Again, one is positive, one is negative, and then they're always going to be switched, the numerator and denominator, which that stands for reciprocal. So some equations that we're going to use, okay, to review algebra. We're going to use a slope-intercept form of an equation, which is right here, this first one right here. And this is y equals mx plus b. A reminder, like I said earlier, that m is your slope and b is going to be your y-intercept, okay? For your point slope form, you have two different forms, and they're both pretty much the same thing. You have y minus y1 equals m, which again, that's slope. That one's not going to change. Is x times x minus x1. So this x1 comma y1, that's going to be the point that we will use, okay? And then same thing over here. This is pretty much the same thing, but there's like they moved the y1 over here, and then they changed the x1, y1 to h and k. So this point is h comma k. And again, that's a point that is going to be on the line. And then on this far right, we have a standard form, okay? The A, the B, and the C are just simple coefficients or constants. These are numbers. They are not neither your slope nor y-intercept, so you have to actually change the standard form of an equation to look like the slope-intercept form if you want to know their slope and y-intercept, which we are going to have to use that since we are working with slopes, and that'll help us figure out if lines are parallel or perpendicular. We cannot tell if the equation is written like this over here in standard form. You cannot tell if they are parallel or perpendicular. They have to be written in slope-intercept form so we can see that slope. And then this formula down here, this one's the slope formula, okay? M equals y2 minus y1. So remember the change in y over the change in x. So that is also from last year. Okay, so let's do some problems with this, okay? So you know parallel lines have the same slope, and you know perpendicular lines have opposite reciprocal slopes. So let's do several examples, and students tend to have a hard time with these parallel and perpendicular. So we're going to do quite a few examples right now, okay? So let's start off with number one. It says write an equation of a line that is parallel to y equals 4x minus 1 and goes through the point 1 comma 2. Okay, so what do we know about this line? We know that it goes through this line, y equals 4x plus 1. You notice I just highlighted the slope. That's in slope form. So the slope of the line is 4. And then it's going to go through the point 1 comma 2. And we want to write this equation in slope-intercept form. So the first thing that I want to write down is, what is the new slope going to be? So our new slope of our new line is going to be the same as that one because we have to make them parallel. So our new slope is 4, so we need to keep it the same. And we know it goes through the point 1 comma 2. So when I'm going to flip back real quick to our equations, see how this says point slope form? That means you know a point and you know the slope. Therefore, you want to use that equation, okay? So we know a point, which is 1 comma 2, and we know the slope, which is 4. So I'm going to write down our point slope formula. So it's y minus y1 equals m times x minus x1. All right? So this right here, this point is going to be x1, y1. And then I'm going to substitute that in. So here we go. Y minus, what's y1? 2. M is 4 because we want the slope to be the same as the other one. And then we have x minus 1 because there's my x1 over here. All right, now we need to write it in slope-intercept form because this is not, so we'll have to do the distributive property here. So we have y minus 2 equals 4x minus 4. And then now all we have to do is add 2 to get rid of that. So our final answer is y equals 4x minus 2. And that is our new equation of a line that is parallel to this one right here. So they have the same slope. So let's try number 2. It says write an equation of a line that is perpendicular. Okay, so now we're thinking perpendicular to this one right here. So I want to highlight that slope right here. Okay, so -2. And then this one's going to go through the point 4, 5. So I'm going to use this point, and then I'm going to figure out what the new slope is. So what is the new slope? So new slope is going to be the opposite reciprocal of -2. So what's the opposite of negative? Positive. Okay, so it's going to be a positive value. And what is the reciprocal of 2? So think of 2 as 2 over 1. So what is the reciprocal of that? 1 over 2. And remember, this one was negative, so we want that to be positive. So our new slope is 1 over 2. So that's important that we have to use that. So we know the point is going to go through 4, 5, and we know our slope is 1/2. And we want to write it in slope-intercept form again. Okay, so I'm going to use the other equation, so that way you can pick and see which one you like more. So the first one I used up here was y minus y1. So now I'm going to use that h comma k, all right? So y equals m times x minus h, and then minus k. Okay, let me make sure I wrote that down right. I'm going to go back over here, look at the bottom. Oh, it's plus k, so it's minus h plus k. See, we always want to double check that stuff. So let's put a plus there. Okay, so let's plug in what we know. So this right here, guys, let me get a different color so you can see. This is going to be h and k, okay? So that's just something that you have to work with. So that's h, k. If you don't like the value, the letters h and k, then you'll probably want to stick to this other one up here where it's x1, y1, okay? But it's the same thing. So I want to just show both ways so that way people can choose which equation they'd rather use. So I have y equals, what's m? We figured it out over here. Our new slope is 1/2. Then we have x minus 4 plus k. Well, I don't want to write k again. K is 5. All right, so now I just need to do the distributive property. See, similar like what I did up there. So I'm going to distribute the 1/2 and to the x and to the -4. So I'm going to get y equals 1/2 x minus 2. Half of 4 is 2. And then I have the plus 5. So you can see how it's similar to what we did up here. See how we added the 2? It's already being shown over here on the other side. Okay, but still the same process because I distributed the 4 up there. Okay, so I just need to add that to write my final answer. So my final equation is going to be y equals 1/2 x, -2 plus 5 is a positive 3. So that is my equation of a line that is perpendicular to this equation right here, okay, because it has an opposite reciprocal of that, and it goes through the 0.45. Okay, let's look at it again, but this time it's a little bit more challenging because it says it is going to be perpendicular, so we need to write an equation of a line that is perpendicular to this, okay? But if you notice this equation, I cannot tell what the slope is, and let me tell you a biggest mistake that kids do. They'll just highlight this number right here, the 12, because it's in front of the x, because that's what I did up here, okay? But this equation down here is not in slope-intercept form, so you do not want to highlight that 12. So let me undo that. So what do I need to do to this equation? So I need to figure out the slope. That means I need to change this to slope-intercept form because I cannot tell right now. It's in standard form. And then it is going to go through this point over here. So I'm going to highlight that. Okay, so, and then this one though, look, this is a little bit different. I get to leave this in point slope form. So the first thing that I need to do is change this equation over here off to my right to slope-intercept form. So I have 12x minus 6y equals 20. Well, I want it to look like y equals mx plus b, so I need to move this 12x over here. So that'll get rid of that. So I have negative 6y equals, I'm going to put the negative 12x first because that's how slope-intercept goes. And then I'm going to divide by negative 6 to everything. That'll cancel out. So y equals negative 12 divided by negative 6 is a positive 2 plus negative 6 goes into that 3 negative because we're dividing by negative. So negative 3, that's what, 18, so 2, negative 3 1/3. Okay, and you could write 0.33 if you want, all right, but I like to leave it as fractions. But that's not really my concern. My main concern that I want to get out of this equation is what is the slope? Because our new slope needs to be perpendicular to that equation right there, okay? So this is similar to the other one, sort of, okay? I need to figure out what the opposite reciprocal of 2 is. So what is the opposite reciprocal of 2? So our new slope is going to be negative, obviously, because that one's positive, and the reciprocal of 2 is 1/2. Okay, so that's my new slope right there. And I know it's going to go through this point. So now I'm going to use my point slope formula. Remember, I did 2 different point slope formulas. I get to use either this one up here or the h comma k one, okay? So I'm going to use the first one. So that means this is my x1, y1, and I'm going to plug it into that formula. So my formula is y minus y1, which I'm going to just straight up write negative 4, equals m, which is my new slope is negative 1/2, times x minus x1, which my x1 is 2. And so now all I have to do is simplify. Well, I really don't even need to simplify that. I can just turn that to a positive like that. And guys, this right here is point slope formula. Remember, I get to leave it in point slope formula. And you just stop right there, okay? So it'll be y plus 4 equals negative 1/2 times x minus 2. This is point slope form. Okay, so that's point slope form. All right, so these are 3 good practice problems on writing equations. Let's see how we can see it in a different format. So let's look at number 4. Number 4 says, are A, B, and CD parallel, perpendicular, or neither? Well, we just need to figure out their slopes to see if they're parallel, perpendicular, or not related at all. So let's do AB over here. And so here's a quick way that most students like to see it. You can either use the slope formula, which looks like this, y2 minus y1 over x2 minus x1, or some kids just like to see it in a little table. Okay, so A was 2 comma 4, and so I'm gonna put a little a right there, and B is 3 comma 6. And so the way you can read the slope off of that is you can just do the little differences right there. So this one went up 1 and this one went up 2. Now remember, just like this formula up here, it's the change in y over the change in x. So y goes on top, so the slope of this guy is 2 over 1. Because remember, the y has to go on top. So there's the slope of AB. Okay, so now let's try the slope of CD. Okay, so CD I will do over here. Remember x comma y. We're going to make a little table. So this would be negative 5. It's good to put them in order too. And then D is negative 4 comma 2. So what does this change by? This changes by up 1, and this one goes up 2. And so remember, it's the change in y over the change in x. So y is over here, so 2 over 1. And they're both positive. So let's take a look at that right there. So the slope of AB was 2 over 1. The slope of CD was 2 over 1. So then that tells us that these 2 lines are parallel because parallel lines have the same slope. Okay, So again, you can use this formula up here, or you can write it in little table format and do the little change in y and change in x. All right, let's take a look at the next one. The next one says find two possible points for E so that AB is perpendicular to CE. Okay, so we did AB already. So I'm going to just rewrite that down. AB has a slope of 2/1, okay? Or, you can just write 2. We usually don't say it like that, but sometimes it's good to leave it in fraction form. And so if the line for CE, which we don't know we don't know E, all we know is C. So, but our new slope for CE needs to be what, guys? It needs to be the opposite reciprocal of that, okay? Or same thing, 2/1. So what is the opposite reciprocal of that? Well, if this is positive, then our new slope needs to be -1/2. So that is our new slope, -1/2. So let's write it in table format, kind of like how we did earlier. So this is going to be CE x comma y, which we're going to make a table. And so C we know. So C is at, let me scroll back up, -5, 0. All right. And we want the new slope to be, remember, this is the change in y. And the negative, guys, we can put up at the top. This is where it gets a little confusing for kids because the negative's usually in the middle. And like some people will say, well, what do I put the negative with, the 1 or the 2? So I'm going to put it over here on this side, -1, and this one's going to go up 2. All right. So the -1 means it goes down 1. So that means the next one's going to be -1. And this is going to go up 2. So don't get confused with negative. Up 2 will be to -3. Okay. And then you can do that one more time because we need two possible points. And you can keep it going, and you can also go in the opposite direction. So let me get a different color. Let me get blue. So we're going to go again down 1, which will be -2. And then same thing here, we're going to go up 2, which that would be -1. So there's my next 2 points. Okay, it'll be -3, -1, and -1, -2. Okay, and you'll notice all I did was from point C right here, I just used my new slope, which was, this is the y and this is the x. So I went down 1 right here, okay? If that is kind of difficult to understand, guys, sometimes you can use a graph, okay? And so if you look at this, let me try to make some space up here. Let me kind of move this over real quick. So those are our 2 answers, right? I'm just going to try to move everything over a little bit. Okay, so let's say you're having a hard time understanding this right here. Here's what you can do next. You can make a little point right here, and you can call that point C, which is at -5, 0, right? And if our new slope is -1/2, remember that means it's going to go down 1/2. And then same thing, down 1/2. Okay, and so to think of that right there, if I'm going to go down 1, okay, from -5 and 0, well, down 1 is associated to the 0. So if I'm going to go down 1, then that means my new y is going to be -1. And if I'm going to go 1 to the right, well, think of the x. Well, I'm sorry, 2 to the right. Well, 2 to the right, -5 would be -4, -3. So -3, -1. And then you can do that again. If I'm going to go down 1, I'm going to go down 1 from -1, right? So if I go down 1, then that means I'm going to go down to -2. If I'm going to go 2 to the right, well, think if that's -3, 2 to the right would be -2, -1. So you see, you can think visually also if you don't like this table. Okay, so that's just to give you another option. All right, let's look at these last two. Okay, last two. Write an equation of a perpendicular line that goes through the midpoint, which this is called a perpendicular bisector of AB. And then it says A is at 0, -6, and B is at 8, -4. Okay, so it's again, sometimes having a visual kind of helps the situation. So I have this point, AB. So here's A, and here's B. And I need to write an equation of a line that is perpendicular to this one and goes through the midpoint. So we have a midpoint here, which means this side's equal to that. And this line is going to go through there like that, okay? Now, don't look at the slopes or anything. I don't know that the slopes are correct, okay? But this is what I want to get a visual for you, okay? So I have to know this midpoint, and then I have to figure out what the slopes need to be, because that's what it requires to find an equation. I need a slope and I need a point. So let's figure out the point first. The point should be pretty easy. That's finding the midpoint of these two. Let me get a different color. So to find the midpoint right here, I just need to add 0 plus 8 and divide it by 2. Remember midpoint and distance from the previous one. And then I'm going to do -6 plus -4 and divide that by 2. So we can do this probably in our head. 0 plus 8 is 8. 8 divided by 2 is 4. And then over here, -6 plus -4 is -10. And -10 divided by 2 is -5. So this is our midpoint right there, guys. Okay, so this is our midpoint. So I know that our equation is going to go through 4, -5. So I want to highlight that because that's important. So it's going to go through that point right there. And now I need to figure out what the slope is, okay? So the slope of AB is, I can figure it out using these 2 points. And once I figure out that slope, I want to do the opposite reciprocal because the other one is perpendicular. So now let's figure out the slope. Let me get a different color. So the slope of our old line is, and I like to do the little table because it's a little bit easier. So 0, -6, 8, -4. So let's see what the change is. The change in y, if it goes from -6 to -4, that means it went up 2, okay? And then the change in x, it went up 8. So remember the slope is rise over run. So it's going to be 2, the change in y, over the change in x, 2 over 8, which that reduces to 1/4. So the slope of line AB is 1/4. So what is our new slope going to be of this guy? Oops. Our new slope is going to be the opposite reciprocal of that. What is the opposite reciprocal of that? Negative, because this one's positive, so this one's going to be -4. Okay, so let me highlight that. So now I know 2 major parts. I know the new slope is going to be -4, and I know it's going to go through that point, 4, -5. So we did the first 3 examples doing this right here. So hopefully you kind of remember that. So I'm going to use my point slope formula because I know a point and I know the slope. So it goes like this, y minus y1 equals m times x minus x1. So your x1, y1 is that point right there. Okay, so y minus -5 equals -4 times x minus 4. Okay, now guys, it didn't say to put it in any type of form, so you could technically stop right there, but I'm going to change it to point slope formula because I think that's the way we make you do that on your homework. Okay, so we're going to do the distributive property here, so that's going to be -4x plus 16, and then I'm going to -5 to both sides. And so my final answer is going to be y equals -4x plus 11. Okay, so it was a little challenging, but you have to realize, okay, if I'm making perpendicular lines, I need to think opposite reciprocal slopes, and then it said bisector, so then I have to find the midpoint of that. All right, so that one was kind of tough, so let's practice it one last time. This is the last example, so let me make sure I have enough room here. So this one says, write an equation of a line that is perpendicular, is the perpendicular bisector of AB, and here's the points for AB. So we'll just say, why is that doing that? We'll just say this is A and this is B. Okay, so what was the first thing that I did? Well, I need to find the midpoint because remember, it has to be the bisector. So again, I'll draw you a quick little picture of what we're doing here. So if this is A and this is B, the perpendicular bisector goes through it like this. Remember, you even constructed this. It's going to go through the midpoint and it's going to be perpendicular. So I need to find the equation of that line. What is that y equals equation? So let's first off start off by finding the midpoint. Okay, so how do you find the midpoint? Let me just write that down. I forgot to write that down earlier. So for midpoint, I'm going to do -6 plus 22 and divide that by 2. And then my y is going to be 10 plus 2, and I will divide that by 2 as well. So let's add that. I might need that calculator. What's -6 plus 22? That would be 16. And 16 divided by 2 is 8. 10 plus 2 is 12. And 12 divided by 2 is 6. So this is my midpoint. So let me highlight that. This is good to get a highlighter, y'all. So that way you highlight the important points that we need. So this is the point that it's going to go through, which is right over here. I just highlighted in pink. So that's 8,6. Now we need to know the slope of AB because then we need to do the opposite reciprocal, because we have perpendicular. We have to do the opposite reciprocal of that. So how do I find the slope of AB? Well, I'm going to make that little table like I've been doing. So this is how I'm going to do the slope of AB. Make a little table. This is X, this is Y. A, let's do the lower number first, -6, 10. And then this one's at 22, 2. So these are really big numbers, but we can figure it out. So let's see the change in Y. What does the change in Y do? It went from 10 to 2. That went down 8. So I'm going to put a -8 there. What did the X do? It went from -6 all the way to 22. So think of a number line. -6 all the way to 22. So that means it went up 28 units. Okay, so what is that slope? Remember, it's the change in Y over the change in X. Let me get a different color here. So the change in Y, this is Y, remember, that's why I put Y on this side, and this is the change in X. So M equals -8 over 28. Let's reduce that, okay? So what goes into both of those? I believe 4 goes into both of those, right? So 4 goes into that -2 times and 7. So this is the slope, guys, of AB, okay? That's what I wrote down right there. So if that's the slope of AB, what is the new slope going to be? So our new slope is going to be the opposite reciprocal of that. So we're going to do obviously positive because that one's negative. So it's going to be 7/2. So let me highlight that because those are my two important things that I need to use to write my new equation. So I know it goes through 8, 6, and the new slope is 7/2. Okay, I'm almost there. Last one. So how do I write the equation out? I'm going to do point slope formula. So I'm going to do y minus y1 equals m times x minus x1. So you're saying, well, what is x1, y1? Remember, it's this point right here. That's your x1, that's your y1. And here's our slope. So we have y minus 6 equals 7/2 times x minus my x1, which is 8. And this is my final answer right there. I can change it to point slope, but it doesn't say that I have to. So I'm actually going to leave this one in, change it to slope intercept form, but I'm going to leave it in point slope formula. Okay, so let me write that down. This is the equation. All it is it's in point slope form. And you can leave it in point slope form if it doesn't say specifically what to leave it in. Okay, I believe on the homework we make you change it to slope intercept form, but we're going to just go ahead and stop there. Okay, guys, so these problems are a little tougher. That's why I wanted to do more examples with you.